All right. So for the next talk, types Boolean Algebras. Yes.
All right. Thanks, Lionel, for the introduction. So as he mentioned, I'll be talking about qualified types with Boolean Algebras. This is joint work with my friends and collaborators at Aarhus, John and Magnus, and my advisor, Ondřej. So what's this talk about? So what's the motivation behind this talk? So you guys might be familiar with Flix, and if you're not, here's my obligatory plug for Flix. This talk brought to you by Flix. Flix is a relatively new programming language that is a multi-paradigm programming language with, for the purposes of this talk, what you should care about is a really cool type and effect system based on Boolean algebras with Boolean unification for inference. Now that's great and all, but there are two major limitations with what we have in Flix so far, namely that there's no support for subaffecting, and there's not that much in the way of a formal foundation of what's proving the system sound. So the purpose of today's talk, or why we're going to talk about this, is we're going to try and fix that. We're going to extend Flix with a limited but sufficient form of subaffecting for the use cases we've seen in practical Flix programs. And we're going to present a rock formalization of a calculus, system FB and FBE, which underpins the new effect system in Flix. So since this is OOPSLA', I should probably remind you what an effect system is. Effect systems augment type systems to track side effects of code. So if you write something down like print hello world, that produces a side effect. Formally, it produces an IO effect in string. You may want to record that to make sure to see reason about what code can perform IO. Except performs a network effect by receiving a connection, and something even as simple as incrementing a ref cell performs an effect by mutating memory. So this is what our effect system in Flix looks like right now. Flix has a type system. It's statically typed, so that makes us all happy. And it will tell us that the minutes to when this talk should start, that's that function over there, is a function that returns int. That happens to be the minutes since the Unix epoch of when this talk should have started and when I should have finished this talk. Now, Flix's effect system tells us that minutes to talk may have the effect non-det because it calls a function, getCurrentMinute, that has effects non-det, and therefore itself could also be non-deterministic as well too. Purity in Flix, well, some functions are pure. If you're just comparing two numbers, well, you perform no side effects, and the annotation for that is just with the empty set. And of course, like any good programming language, Flix is also effect polymorphic. So here you can write down map. Map applies a function to a list of arguments, here restricted to int. And naturally, map has the same effects as the function it applies. So applying map to is overdue, which we saw earlier, is still pure. It has the effect set of empty. Now, Flix has a nice feature, which is pretty unique because it uses Boolean formulas for effect annotations, is that it supports a notion known as effect exclusion, where you can say I can be effect polymorphic, but as long as you don't use some set of effects. So here, if you power map, which runs a function in parallel, it should accept most functions, but perhaps shouldn't accept functions that perform IO, because those IO effects might overlap in bad ways. So we might write that down in Flix as saying, well, f takes a function f that takes in an arbitrary effect set ef, as long as f has to be parameterized by ef, but can't contain IO. So you can now, of course, you can apply power map to functions that don't do IO, like is overdue, and in that case, ef is filled in with something like IO, where is overdue is empty, so IO minus O is empty. So there are some limitations to this story. So when one limitation becomes apparent when you try and perhaps write code incrementally in Flix. So if you wanted to write a program to send that monitors when this talk should be done, well, you might have to call a minutes to talk to figure out when the talk should be done. You have to talk to a server that uses connect, which uses TCP connect as an effect, and you have to do some IO, so that uses the IO effect. So you use all these three functions. The effect fetch set of your program should be non-det, TCP connect, and IO. So you start writing this function, and since you follow the principles on how to design program, you start by writing down its signature and incrementally building it up. And debugging from that. So you might write down a small fragment that perhaps fetches the time to when this talk should be done, and then does some tracing, debugging I/O to help you build up your program. And you write down the proper signature, and you think, oh, this should work, but it doesn't, because you get the problem that, well, the Flix compiler will tell you that it can't unify the effect formulas non-det TCP connect and I/O against non-det and I/O. Now, what's the problem here? Well, the problem is that we said that report time would do 3 effects, but the fragment we've implemented so far only does 2 of them, non-det and I/O. It doesn't talk to a server. And what we need to fix this is some notion of subeffecting, because, well, some programs and expressions are unfairly rejected, just like this. And this has real consequences in Flix as well, too. There are 47 unchecked effect upcasts in Flix's standard library, and they're there because of reasons like this. And we'd also like formal foundations. So the idea we're going to do to fix both of these is we're going to build up on some work that does type qualifiers with lattices and polymorphism. Now, so that brings us to what we've done so far. So we want a calculus with a type and effect system that has parametric polymorphism, language effects that is described with Boolean algebras and Boolean formulas, and a subaffecting relation based on set inclusion accounting for effect variables. So there's a lot of work on effect systems out there, but there's few grounded on anything like Boolean algebras. Coincidentally, like the closest system that we're thinking of was a system that I presented last year at OOPSLA', which combines some pretty cool work from 1999 of Jeff Foster on type qualifiers, but unifies that with polymorphism and subqualification through qualifier variables, with the subaffecting based on, and we use that to implement an effect system with the subaffecting based on the lattice order. Now, what's missing is that lattices are not Boolean algebras, but Boolean algebras are thankfully lattices. Every Boolean algebra is a lattice. Top and bottom in the Boolean algebra is the same thing as top and bottom in the lattice. And what's new, the only difference between a Boolean algebra and a lattice is that you have 2 new rules for dealing with Boolean algebras, namely rules for dealing with negation, and you have to be able to distribute meets over joins and joins over meets. So we formalized that, and it's actually not too hard. If you add those 2 or 3 extra rules to account for the extra Boolean algebra properties, you can turn a system on lattices into a system on Boolean algebras, a qualifier system on lattices to a qualifier system on Boolean algebras. And we can use that to build an effect system, the rules of which are right there. But I don't want to bore you with that, so if you're interested in how that's done or in the rock proofs, I'll kindly refer you to the paper. Now, that's really nice in theory, but we also want some results in practice too. The system I've just shown you gives you a formal model for a potential Flix system based on Boolean algebras in Flix, but how do we actually implement this? Because Flix comes with an already very powerful system for type and effect inference based on Boolean unification. Adding general subtyping and subaffecting can be a bit messy. And if we actually try and do that, it would be a bit messy, and we leave that for future work. But as it turns out, for the applications we've run into in Flix, we can get away with 3 limited forms of subaffecting at an abstraction site where you allow variance, you allow the effect set of a lambda to be a little smaller than the effect set of the context that expects it. Subaffecting at definition site, where you allow the effect of the body to be a little smaller than the effect of the declaration, and I guess similar to that, subaffecting at instantiation site, where you allow the effect set of a trait definition to be a little smaller than the effect set declared at the start at the definition of that trait. And if you implement all 3 of these things, you can actually get rid of most of all the cases where we see upcasting in Flix. Now, how do we do that? Well, concretely, we have this Boolean unification engine that allows us to unify effect constraints involving equalities if we want subaffecting at these 3 slices, then all we need to do is add a slack effect to the unification constraint to allow for subaffecting or slack. So concretely, in our example that I filled earlier, you would unify the body against the effect variable b, you would unify, but you would allow for some slack between unifying that effect variable b against the declared effect set of that function. So here, you could, when you do the Boolean unifications, you could sub in b as equal to, well, the calculated effect set of the body, which is non-det and IO, the slack to be TCP connect, and it all just type checks well. So empirically, this gets rid of all the upcasts in the standard library, and the performance impact on type and effect inference when you actually compile code in Flix is under 5%, which is really nice. Even though you introduce all these slack variables, you don't really mess with the compiler and its performance. So you can still compile code practically. So what have we done? We've presented a qualifier system that we've used to build up an effect system based on Boolean algebras in Flix. This can also be used to go and implement other systems that we've also seen in Flix, such as on restrictable variance, nullability, and information flow. And we've implemented this nicely in Flix, and we've shown that you can use this to remove all the effect upcasts in Flix's standard library, making it more usable and more safe. So if you're interested in the proofs, like the artifact and the papers are all online. And if you're interested in playing around with Flix and our new subaffecting system, you can download it at flix.dev, and right now, you'll have to turn on the feature flag, but shortly, this will be live in the mainline Flix distribution. So thank you.
All right. Any questions? OK, so I have one question.
Sorry.
How does this compare with the system we presented earlier?
That's a good question. So I think both systems are cool, but I think they approach the design space from 2 different approaches, right? So with the system that was earlier presented, right, you have a more general system involving negation on types, which I think allows you to do some really cool hacks to the type system, but it also comes with some complexities as well too, right? Whereas here, we're just looking at just adding negation in specific and certain restricted locations, namely in qualifier position, right? So you don't get as much expressivity, but you also get a simpler system. So I think there's space for both in the design space. It's just a matter of how expressive you need to be versus if there's a need for simplicity in your type system as well too.
All right, thanks. Fair enough.
Thank you.
We have more questions. So.
Oh, wow, all right.
Hi, I'm Christo from Insight. I was wondering about the effect system of Flix. If a new effect is added in the future, let's say does blocking I/O or something like that,
sure,
and it needs to be added to the standard library, would this break all client code, or does the language have a way to say this function has whatever effect so that any standard library changes don't affect it?
So I guess when you add a new effect, you're asking if the standard library changes wouldn't break it?
If user code would need to be adjusted to mention that effect as well?
No, I don't believe it would break right now. But I guess if we want to talk about this more offline, I'd love to.
Okay.
Okay.
Thanks. Yeah, sometimes in Flix we have things like an iterator, which is parametric over some effect.
Right.
Does this just work with that kind of thing?
So it works. So I believe this should just all work with Flix with the iterator trait with Flix. In fact, it gets rid of one really annoying problem with iterators and mapping, and that Flix's iterators are all done in a weird continuation passing style, and that needs upcasting because of the base case of the continuation has no effect, and whereas mapping could have some effect. So this actually fixes the problem with the iterator system.
Okay. Thank you.